The second of the linear array algorithms we're going to look at is actually Bubblesort. We're going to skip the binary search for now because we cannot do the binary search, the very efficient binary search, until we have a sorted data structure. And there are two sorts we're going to look at: Bubblesort, selection sort. Do keep in mind that as I implement this, it is much easier to understand the algorithm to look at YouTube videos or to work with cards around the table or me up on the board, but this is just to show you that there is code associated with that, and that code does make sense. So here we go. We're going to call a Bubblesort. For now I won't send anything, but I do think we realize we're going to be sending something shortly. So again, just to start, now we can think about parameters and return values. Parameters, well, sure, just like before, we are sending this to another method, and so in fact here we could just use this global, but usually what we will be doing is sending an array. So let's take this array and send it as an argument down to our Bubblesort, which shall receive it as an argument of type int array, and we could call it the same thing, but since this is general Bubblesort we're making, let's just use the classic ARR. The next thing to think about is whether we're going to need a return value. And without getting too deeply into object-oriented programming, the fact of the matter is this and this, well, they're two different variables. They are different variables, but they point to the same thing. They both point to that array. And so if we sort this array, the one that we're using up in the main is sorted. So we do not need to send anything back. We simply need to sort. How are we going to sort? Well, there are a couple of things that we need to keep track of. And those two things are going to help us make this an efficient Bubblesort. I didn't call this smartest Bubblesort, it's just the Bubblesort that you're going to use if you do use a Bubblesort. And do keep in mind that even though it's not efficient in a lot of cases, sometimes it is. So it is an actual real sort that people do use. So two things that will make this most efficient are, one, reducing the number of comparisons each time, because generally we're going to be going down through the array and comparing neighbors to see if the neighbor to the right is in the wrong place. It needs to be over here. So if this is greater than that, we're going to swap. So you can see that I've done 3 passes here, and the first time through it's the 99, which is going to bubble up to the last element because it is greater than that, and it will be greater than that, and greater than that, and greater than that. So as we bubble things up to the top, we will no longer need to deal with them. So having made 1, 2, 3, 4, 5 comparisons the first time, 99 will bubble up to the end. And the second time through making 1, 2, 3, 4 comparisons, 88 will bubble up. And so we want to reduce the number of comparisons that we're making each pass. First pass is going to be 5 comparisons, 1 less than the length. The second pass is going to be 4 comparisons, and then 3 comparisons, and if we need it, 2 comparisons, and so on. And that's the other thing we need to keep track of, is whether in the process of doing these passes, things do become sorted. And you'll see here after only 3 passes, 1, 2, 3, 23, 88, 99, it is already sorted. So those two things we will first of all establish to help us make this efficient. One of them is a Boolean we'll just call sorted. And the other is going to be the number of passes. N would be fine for that, int n. And we're going to just start by saying it's the array.length. I've already said that it's actually the first pass going to be 1 minus that, but each time through we're going to lessen that value. So let's lessen that n value inside the loop. What kind of a loop is it going to be? Well, it's not going to be a for loop because we don't know exactly how many passes we're going to require, because as I already said, it may become sorted in the middle of doing the maximum number of passes. So we'll use a while loop since we're not sure of exactly the number of times that we're going to loop. We're going to loop while not sorted. And I didn't mention it as I wrote it up there before, but we did initialize this as false so that we can at least get in once to see if it is sorted to begin with. So while not sorted, yes, what are we going to do? Well, we are going to compare. We're going to make comparisons. We're going to say if this is greater than that, we need to swap them. And in that case, they're not. But like this would be the first swap that would take place. If this is greater than that, which it is, we need to swap those two values. And then 99 is going to swap and swap and swap and swap during the first pass to make it up to the end. So what did I say there? I said if, and I was looping. So for int I starts at 0, I is less than n. We'll deal a little bit more with this shortly. I plus plus. So comparisons. If the one on the left is greater than the one on the right, using our ARR and our counter being the I plus 1. So if any given element is greater than the element to its right, we're going to swap them. And we swap in 3 steps. So for example, if we were swapping 99 and 88, we could just overwrite the 99 with 88, but then we'd have 88, 88, and we would have lost the 99. So the very first thing that we're going to do is take that I element and put it someplace in a temporary value. And this is an int array, so int temp is going to be assigned ARRI. And then we do the replacements. The I is going to be the I plus 1, and the I plus 1 is going to be the temp. It's going to become the value at I plus 1. So for example, if we're looking at these two, if this is indeed greater than that, then that's going to become that. That's what I just did there. And then the second one, the I plus 1, becomes the thing which we had overwritten but saved temporarily as temp. But we're not quite finished because this n we haven't adjusted yet. Here's where we're going to adjust that n. The very first time through, the n minus minus. So the very first time we loop through doing compare, 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 we're not going to compare 6 times. We're going to compare 5 times because the n's gone down by 1. The second time through, since that's already sorted, we only need 1, 2, 3, 4 comparisons, and so on and so on. That's handled by the while loop each time it iterates, reducing the n by 1. Finally then, what about this sorted, while not sorted? That doesn't change. When does not sorted change? Well, in here, only when we get in and we actually do a swap do we know that it's not sorted. So that needs to change. That not sorted, even before we get into the loop, needs to change to an assumed true. So we'll assume even before we start the pass each time that sorted becomes true. And only if we get in and we do a swap, for example here, we're definitely going to be making swaps because 23 is greater than 2. So in the middle of doing all of the comparisons there for the second pass, an assumed true will become, again, false. Yet, for this final pass that we need in this case, take a look. We do go through it, so we ended here with sorted to be assumed false. We come back up. We do another pass here. We assume sorted to be true before we even start. Look at those two. Don't get into the swap. Look at those two. Don't get into the swap. Oh, it is sorted. And we know that because we declared it to be true before we got in, and we never, that particular pass, with those 3 numbers, converted sorted back to false. So we go back up, and the while says while not sorted. Well now, double negative, that's not true, because it is sorted. Let's just prove this by printing out our values before the bubble sort and printing them out afterward. So now we're dealing with this one. And just a simple loop through and print out the values. We'll do it before and after. and just put a line in between. And we'll run it and see that it does indeed take unsorted values and sort them.